I'm Stephen Jenks. This is the Visualization Lab in Cal AT2 at UC Irvine. And we've got the HiPerWall, the original HiPerWall here, and then two commercial HiPerWalls that are essentially systems that are on sale, licensed from the university. The technology is licensed from the university. So the HiPerWall is showing right now some very high resolution imagery. So it's showing a rat brain, which is a 400 million pixel confocal microscopy image, and also an image from an artist named Max Lyons that shows a construction site and can zoom right in to be able to see the signs. We can also view images from the Hubble Space Telescope, which is an 800 million pixel. Stanford Medical School, a billion pixel image of human heart tissue. So we can get down and see the red blood cells.
Everybody understand the licensing system? So that's important. So we can't issue a license to a customer until...
That's 54 megapixel displays. So each of those is very high resolution, and together they equal 200 million pixels. And then we have commercial displays around here that are bigger and brighter, but not nearly as high resolution. So this is still one of the highest resolution systems in the world. Yep, it was originally the very highest resolution by twice as much as anybody else. Now it's probably fourth or fifth in the world. So our friends at UC San Diego have a bigger one. And I think NASA also has a somewhat bigger one. Medical, earth science, studying climate, aftermath of disasters. So we've got images of Hurricane Katrina. This is Gulfport. So after Hurricane Katrina, stuff is in the middle of the road, for example. There are houses that have been picked up and dropped. This whole neighborhood is just trashed. So it's all very interactive, which was the way we designed it. So things can be quickly zoomed and panned and moved around. So the whole intent is to be able to explore the data visually. So you can very quickly get an overview of the situation. You can, in this case, we have a before image and an after image, so you can see the changes, and then you can plan your ingress and where people are going to need rescuing. So yes, absolutely. These are microscopes, and essentially what they do, I think, is they stain it and lay it out, and then shoot individual pieces of it, and then stitch them together into a really big image. So one camera doesn't capture that. It's individual stitches that have been put together, and then you end up with a billion pixels. So, and that can be done very inexpensively now with regular cameras. So here's an example at Anza Borrego State Park.
I do the licensing generation.
Very high resolution, nearly 200 million pixel image that was put together for just a couple $100 worth of hardware. One file, and it's a few hundred megabytes up to gigabytes. So depending on the complexity of the data and so on. So yeah, I mean that's kind of our point, is if you needed to load a gigabyte worth of data on your PC, it would take you 10 or 20 seconds probably to load it, assuming nothing else was going on. And yet here we can bring that image up just that fast. It just comes right up. So our whole point is that we're able just to look at exactly what needs to be brought up on each monitor and only do that amount of work. So we're very conservative of the amount of work that each system does, and therefore they share the load, and it's a big parallel computing problem. Behind this one, it's one computer powers two monitors. The other ones is one computer per monitor, and they're built in on these. and then these ones have little tiny ones strapped to the back.
Training, which is how to install